Welcome to the ML Dropout. In this video, we're going to go over how to use apply functions in Pandas. So we'll cover what are apply functions, we'll look at the data that we're going to use in this example, and then we're going to cover the bullet points below, which basically outline different types or different ways that you can use an apply function. And finally, we're going to top it off with Lambda functions and column level statistics. So let's jump into it. So we're going to import pandas as PD, numpy as np, and then we're going to import plotly. From plotly, we're going to import the graph objects as go, and we're going to use that to do some visuals later on. So we'll shift enter, run that, and then that will bring us down to the load explore data. Let's load in our data. So we're going to read the CSV. This is going to be Forex data. So what we have here is we have time, and time is going to be in 1 minute increments. We have this numerical year, numerical month, the instrument, which is the Australian dollar to US dollar currency pair. And then we have our open, high, low, close. And with this data, we're going to illustrate how to use different pandas apply functions. So let's just look a little bit deeper into our data. We'll do describe. So it's going to show us the count. So it's 241 rows, right? And if you look at the timestamps here, that actually makes sense because if we're saying 5 a.m. to 9 a.m. inclusive of 9 a.m., that it should be 241 minutes. Then you can see, mean or the min, standard deviation, max, all the percentiles. Okay, cool. Data looks pretty good. Now we're just going to get a little plot to get a feel of like what this might look like on a chart. So when we're looking at the chart, we see that it moves up 1/2 of a cent. If you're familiar with Forex, 1/2 of a cent is about 50 pips. And if you were to be trading, let's just say 10,000 units of currency here, which you can easily trade with like 200 US dollars, this would be a $50 trade. Like if you were to buy and sell here, just giving context on like how big this movement is. So we saw it like this. Let's look at it as a candlestick chart because this is, financial data. So we're going to use plotly. So this is where plotly comes into the picture. So here we're just going to say go figure. And then we're going to say, what is our data? Our data is going to be this go.candlestick. So again, we're using the go. And inside of the candlestick, we're going to define X to be the time column in our data frame. Open is open, high is high, low is low, close is close. And then when we do this fig.update layout, we are adding our title, and then we're telling it to put the title in the center of our chart, and then we're saying show. So this is our chart. Okay, if we wanted to, we can zoom into different pieces. This is all, fun to play around with. Highly recommend learning Plotly. I'll definitely have videos on this in the future, but it's not the focus here, so let's move on. So first we're going to get into using an apply function to do row-wise calculations. So row-wise calculations are when you have two different columns, let's say column A and B, and you want to create a column C that's maybe A plus B. That would be row-wise calculations because you're saying in every row, add A and B to get C. Okay, so that's what we're going to do more or less here. We're going to do A minus B. So we're going to create this function. So in Python, to create a function, you do def, you give your function name, and then you give your inputs. So the first input is going to be the row. It's going to be the values in our row. Then it's going to be the name of column 1, the name of column 2. So we're just passing variables. And then what we're going to return is row column 1. So it's going to be that cell or that value minus row column 2. Okay. Shift enter. Our Jupyter Notebook now has that function. We're going to then use that to create two different columns in our data frame. First is going to be delta. So we're going to look at the difference between the open and the close. Okay. So the way we do this is we do df.apply. We're applying this to the whole data frame because we need to pass in all of the columns. Then we're saying calculate delta. So what are we applying? We're applying this function here. We're applying calculate delta. The arguments that we're passing in besides the row, the data frame is going to know that we're passing in a row because we're specifying axis equals 1. So row is already going to be passed in. So the arguments that we're passing in now are going to be column 1 and column 2. And again, the function is getting the row from this df_apply because we're telling df_apply we're doing this on axis equals 1. Axis equals 1 means that this is going to be a row-wise calculation. If we were to do something like axis equals 0, this would not work. Okay. Similarly, we're going to get the range, and the range is just going to be the same thing, but the high and the low. So we're going to look at the range of a candlestick. So if we were to come in here and zoom in onto, let's say, this big green candlestick, okay, this solid bar and this solid bar here for the square, this large, like thick square, that's going to be your open and your close. That's going to be what we look at in the delta, the range is going to show us the lowest value to the highest value. So it's going to be like the whiskers on your box and whisker plot, or the wicks on your candlestick. So Shift Enter, we ran this. Let's look at this in our data frame. So now we can see we have the delta, we have the range, and just to validate, did this work? Okay, so delta is supposed to be open minus close. If we do 0.63405 minus 0.63411, we should have negative 0.00006. That checks out. Now if we do high minus low, first, that should always be a positive number. High should always be higher than low, so these should all be positive. Second, if we look at the difference here, it's basically going to be this 11 minus this 3, which gives us that 8. That checks out. It did what we thought it was going to do. So now let's get into using an apply function to do column-wise formatting. So we're going to create this column called minute, and what we want minute to be is we want it to be the numerical value of the minute from the time. So again, if we look at our data frame, we have month and year. I said it backwards, but we have year and month, right? And they're both integers for the year and the month. And we can do group by on year, group by on month. In some cases, this is very useful. Well, now we want to do the same with minute. So what we're going to do is we're going to use this pd.toDateTime. So pandas.toDateTime. And what pandas.toDateTime is going to do is it's going to take an input of a pandas series. So we're going to pass in df time. And then given that input of a series, we can do .dt. And what this .dt essentially does is it enhances that series to be able to access date time properties. So basically it means that now we can chain something like .minute, .hour, .day, .second, and it's going to extract that particular value from this date time series. So we're going to say .minute, it's going to return minute, so Shift Enter, let's run that. Okay, and let's just get a quick peek at what our data frame looks like now. Now we have minute, and minute is always going to be, the numerical minute before the next hour. So this checks out. It's what we want it to be, 59:59. Now we're going to do something else. So here, what we're going to say is, maybe I want to do some kind of categorical variable, right? And when I say categorical, this one's technically going to be an integer. But what we want to do is we want to say, hey, you know what? Hours can be grouped into 4 different periods. And we want to classify a minute as being in the first quarter, second quarter, third quarter, or fourth quarter of an hour, right? We want to assign it to one of those periods. So that's what this function does. It takes the input of a minute, and then it takes p. P is going to be the length of your period, right? So if you want a period of 15 minutes, 10 minutes, 30 minutes, whatever, you can define that. And so what it's going to do is it's going to take that minute value and divide it by your period, p, and it's going to round it down to the nearest integer, and then we're going to add 1 because we don't want it to be 0 indexed, we want it to be indexed starting at 1. So instead of periods 0, 1, 2, 3, we want periods 1, 2, 3, 4. So Shift Enter, let's run this, and now let's apply it, okay? So this df hour period is going to equal df minute.apply, assign periods. Now, notice that I did not put axis equals 1 here, okay? Because we're applying it to a single Pandas series only has one axis, so we don't need to specify that. It already knows what we're trying to apply it to. And essentially we're just going to say assign periods because we have already set our P to be 15. If we wanted P to be something else though, we would just pass something like 15 here, and then it would take that value. Now let's look at our data frame, and we can see these hour periods. And so we can see that it is properly assigned, anything within the first 15 minutes to be 1, anything in the last 15 minutes to be 4. If we really wanted to get like nitty gritty and be like, okay, show me like a better example, let's do 20. We can come in here and see where it switches from 2 to 3. Just again, kind of solidifying, yes, it's doing what we think it's doing. So moving on, let's get into column-wise calculations. So let's say we want to do a moving average, okay? So if we want to do a moving average, we're going to have to do our Pandas series dot rolling. Rolling is going to say it's going to be a window function of 10 rows, and then we're going to specify what is the aggregate type of value that we want to see in this window function. So because it's a moving average, we want the mean. Mean is equivalent to average. So we're going to call this our moving average 10 close because it's just going to be, 10 rows, 10 minutes. And then we're going to do the rolling window of 10, and we're getting the mean. We'll hit Shift Enter. And we'll see that at first it's going to give us these nan or does not exist or null values. That's because there are no values until it has passed that threshold of whatever your window is, right? So if we really want to see when does it start, we can do something like that. And we can see that in this 9th row, which is technically your 10th row because Pandas data frames are 0 indexed. If we come here, we see it starts at 0. So in row with the index value of 9, which is your 10th row, we see our first value for the moving average, which is going to be the average for your last 10 close values, right? And then now if we want to get fancy, we'd be like, oh, are we above or below, blah, blah, blah. There's cool stuff you can do with that. This isn't the video for it. So kind of giving more of an example, moving on. We're going to do the same thing, but now we're going to show you how you can add or subtract when you're doing your apply functions. So here what we're going to do is we're going to calculate the upper and lower variance of our values. And the way we're going to do that is we're just going to say, okay, what are our values at that point in time? And then we're going to say, okay, I want a window function of the last 10 rows, so the last 10 minutes. We're going to calculate the standard deviation, and then we're going to multiply it by 1.96. Now, the reason why we're multiplying it by 1.96, for those of you who have some stats background, it's because 1.96 is the z-score for your 95th percentile. So by using this for our upper and our lower variance, we know that we are essentially, capturing anything that's important in our variance, and everything that's outside of that is going to be an outlier. So Shift Enter. Again, they're going to be null at first. We'll come down here, run this, see when they start to get calculated. Okay, and what we want to see is that we want to see that this one is above our moving average, and then this one is below our moving average. And that's true, right? The moving average should always be between these two numbers. Otherwise, we did our math wrong. Somehow, we told Python to do it wrong. So moving on. Now what we're going to do is we're going to take what we just did and we're going to visualize it using some candlestick charts that we're going to add traces to. So again, I'm not going to go full in depth on the Plotly here, but we're going to basically create this trace for the candlesticks. We're going to create a trace for our upper variance, a trace for our lower variance, and then we're going to create a figure that has all three of those traces. We're going to give it a title, a y-axis title, and an x-axis title. Shift Enter to the run. And now you can see our plot. And if we wanted to zoom in here, we can see how at certain times the variance might seem like it's expanding, and how at other times it might seem like it's collapsing. And it might give you a general idea of like when things are getting more or less volatile, right? So if we were to come in and look here, oops, too far. You see this huge candlestick, and what that causes is some expansion. You see this huge gap right here compared to like how narrow it is up there. Okay, cool. That's all we're going to touch on this. Again, I'll make more videos on how to make charts like this in the future. So now we're going to get into Lambda functions for column-wise, or what some might call element-wise calculations. So we're just going to reread our data into a new data frame. We already know what it is here. That's great. Just showing that it's the same. And now we're going to use a Lambda function. So what we're going to do here for this first Lambda function, it's something that doesn't really make sense in practice, but it's a great illustration. And that is we're going to square our numerical month value. So we're going to create this column, month squared, and month squared is going to equal df2, because we're using df2 now, month, because month is this integer value, and we're going to do dot apply, and here's where the Lambda function comes in. We do Lambda, whatever we want to call our variable. It doesn't have to be x, but it's whatever we want to call our variable. Then you do this colon, so that says, okay, I've said we're doing a Lambda function. This is the variable we're going to use. Colon says everything on this right side is the function itself. So we're going to do x, and when you do the star star, that is to square something, or to cube something. It's to put something to a power. and then the 2 means to the second power. So we're going to square this value. So let's run it. Let's look at it. 11 squared is 121. This checks out. So now what we're going to do is we're going to take our open value, this right here, multiply it by 100 so that the value actually means something. And then we're also going to square it using a lambda function. So not much different. We say, okay, what is the new column we want to create? What is the column we want to use? Dot apply, lambda. What is our variable? Again, doesn't have to be x. Here we call it price. Okay, price times 100 in parentheses, square that, boom. Now we get this number. Remains more or less constant because there's not much fluctuation there, right? Now let's do one more lambda function. So we're going to say date equals time dot apply. The lambda is going to be lambda val. So again, just showing you a new variable name. Now here's something that's new. You can cast the type of that value. So we're going to cast the string. And then if you're familiar with Python, you know that in strings, you can actually manipulate them as if they were an array. So if I were to say a equals cat, that's a string. And if I do a0, it's treating that string like it's a list or an array, and it's going to give me back that first value. If I do a-1, it gives me back the last value, which is this t. So what we're saying is give us the first 10 values of time, right? So we can put 0 here. You don't have to put 0 here. So :10 means index 0 to 10, not including 10. So run this. Let's look at it. And what we have in date now is actually the date, right? So here we have this timestamp where we have date mixed with your time. Over here to the right, we purely have date. And this is useful, again, if you want to do any kind of group by functions. Maybe you want to group cells by date. You want to group messages sent by date, usage by date, whatever it is. This is generally going to be more useful when you're doing actual analytics than this timestamp is, unless you're doing something with time series data. Now, finally, we're going to get into column level statistics. So all we're going to do here is show you that if you specify a certain column, you can apply various pre-built functions from NumPy that Pandas has built in to your series. So we can do mean. This will tell us the mean of the whole column. Standard deviation, STD. Var for variance. Max for your max value. Min for your min value. Thank you so much. I hope you enjoyed.